Assalamualaikum and hi everyone. For this video, we will be presenting about floating solar project in Malaysia. Let's get to know our group members first. Without further ado, let's get to know what is actually floating solar project.
Good morning everyone. Today I will introduce the topic of floating solar project in Malaysia. So floating solar project, also known as floating photovoltaic system, refer to solar panels that are installed on the surface of water such as lakes, reservoirs and dams. Similar to regular solar panels on rooftop, these panels capture sunlight and convert into electrical energy. A simple way to imagine this is like a solar power station that floats on a boat on the water. Instead of using large areas of land, we use an empty space on water to generate clean electricity. This technology is becoming increasingly important as countries, including Malaysia, look for more sustainable ways to produce energy while reducing dependence on fossil fuels. Floating solar projects have great significance in Malaysia because our country receives abundant sunlight through the year due to its tropical climate. This makes solar energy a reliable source of renewable power. One major advantage is that it saves land space. We can compare it to a building or parking lot above a lake. Instead of clearing a forest to create more land, in the same way, floating solar uses unused water surface while preserving lands for agriculture, housing and other purposes. In addition, generating electricity from solar energy helps reduce the burning of fossil fuels, which lower carbon dioxide emissions and support a cleaner environment.
Next, we will be discussing about scientific instrumentation and application concept.
So now, let's talk about the scientific instrument we use to manage a floating solar plants. Because these projects are floating in the middle of a lake, we rely heavily on smart devices. First, we use pyranometers, which are specialized sensors that measure exact solar radiation. Second, we place temperature sensors under the modules to track how the water's natural cooling effects improve energy efficiency. All of this live data is fed directly into a SCADA system. Think of SCADA as the digital brain of the plants that monitors the health of every panel and alerts engineers immediately if there is a power drop or an issue. When transitioning solar technology from solid ground to open water standard, engineering simply won't cut it. We have to overcome unique environmental forces which bring us to the core engineering components that make nearshore and the reservoir solar farms possible. First and foremost is the structural foundation, the HDPE floating buoys. Made from high-density polyethylene, these platforms are the unsung heroes of the system. They provide the precise buoyancy required to keep heavy equipment afloat while being chemically engineered to resist constant UV radiation, thermal expansion and long-term water degradation without cracking or corroding. Mounted directly onto these buoys are specialized anti-corrosive dual-glass bifacial solar panels. Standard land-based panels would quickly fail under the constant mist and 100% humidity of a marine environment. These modules features dual glass encapsulations to seal out moisture entirely. Furthermore, because they are bifacial, they capture light from both sides, absorbing direct sunlight from above while simultaneously harvesting the high albedo effect, which is the sunlight reflecting off the water surface below, dramatically increasing our overall energy yield. Moving into the electrical architecture. Safely transporting high voltage electricity across water requires flawless isolation. This is achieved through advanced waterproof cabling. These are not your average wires. They feature multi-layer marine-grade insulation designed to completely block moisture entry. By preventing water ingress, these cables eliminate the risk of catastrophic short circuits, mitigate galvanic corrosion, and prevent signal degradation, ensuring that the power generated safely travels to the onshore grid. And finally, we have to address environmental dynamics like wind, waves, and current. The entire system is held in place by dynamic mooring and anchoring system. Heavy-duty, high-tensile ropes or marine chains connects to the floating matrix to heavy concrete anchors resting on the bed of the lake or reservoir. What makes this system brilliant is its flexibility. It allows the floating platforms to naturally rise and fall with fluctuating water levels. This dynamic tensioning is absolutely crucial for structural integrity, ensuring the entire solar farm can easily withstand intense with loads and heavy currents, particularly during turbulence.
Let's take a look at the real-world implementation in Malaysia, shall we? When we think about solar energy, most of us picture solar panels covering rooftops or stretching across large open fields. But what if these panels could float on water instead? While it may sound like a futuristic idea, Malaysia is already turning this concept into reality through floating solar technology. By transforming lakes and reservoirs into clean energy hubs, the country is exploring innovative ways to generate renewable energy without competing for valuable land resources. One of the most exciting examples can be found at Tasik Kenyir in Terengganu, the largest man-made lake in Southeast Asia. Imagine looking across the vast surface of the lake and seeing thousands of solar panels floating on the water, silently capturing sunlight and converting it into electricity. This ambitious project demonstrates how a natural resource that has long supported hydroelectric power can now play an even greater role in Malaysia's renewable energy future. What makes the Tasik Kenyir project truly remarkable is that it does not simply introduce a new solar farm. Instead, it transforms an existing hydroelectric reservoir into a dual-purpose renewable energy facility. By combining floating solar technology with hydropower infrastructure already in place, the project creates a more efficient and integrated energy system. Rather than building entirely new facilities from scratch, Malaysia is maximizing the potential of resources that already exist. The scale of the project is equally impressive. The first phase is expected to generate around 500 megawatts of electricity, and future expansion plans could increase its capacity to as much as 2,000 megawatts. To put this into perspective, this amount of electricity could support hundreds of thousands of households. As the project grows, it has the potential to become one of the largest floating solar developments in Southeast Asia, showcasing Malaysia's commitment to large-scale renewable energy innovation. However, major projects like Tasik Kenyir do not happen overnight. Before implementing floating solar system on such a large scale, Malaysia first explored the technology through smaller pilot projects. One notable example is the Floating Solar Research Initiative that is conducted by TNB Research,
which was designed to evaluate how floating photovoltaic systems perform under Malaysia's tropical climate conditions. These pilot projects acted as testing grounds for the technology. Researchers examined factors such as energy efficiency, durability, maintenance requirements, and long-term performance. The results were encouraging and demonstrated that floating solar system is able to operate effectively in Malaysia's hot and humid environment. Interestingly, the water beneath the panels helps keep them cooler, allowing them to maintain efficient performance throughout the day. The success of these pilot studies provided valuable insights that helped pave the way for larger developments such as the Tasik Kenyir project. They showed that floating solar technology is not merely a theoretical concept, but a practical solution that can be adapted to local environmental conditions. Overall, these projects illustrate how Malaysia is moving beyond traditional approaches to renewable energy generation.
From pilot-scale research initiative to one of the region's most ambitious floating solar developments, the country is actively demonstrating how innovation can be applied in real-world settings. The Tasik Canoe project and other floating solar initiatives serve as powerful examples of how Malaysia is harnessing its natural resources in smarter and more sustainable ways in order to meet future energy demands.
Let's dive into the benefits, challenges, and also future development of floating solar project in Malaysia.
Let's talk about the benefit of floating solar project. One of the main benefits of floating solar project is that they generate renewable energy from sunlight. Unlike fossil fuels, solar energy is clean and sustainable because it does not produce harmful greenhouse gases during electricity generation. By using solar power, Malaysia can reduce its dependence on non-renewable energy sources and move towards a greener future. Another important advantage is that floating solar system save valuable land space. Traditional solar farms require largest area of land which can be expensive and limited. Floating solar panels are installed on reservoirs, lakes, and dams, allowing the land to be used for agriculture, housing, or other development. Floating solar panels can also help reduce water evaporation. Since the panel cover part of the water surface, they provide shade and reduce direct exposure to sunlight. This helps conserve water, especially during the hot weather, making it beneficial for water reservoirs and dams. Floating solar technology is environmentally friendly because it generates clean electricity without causing air pollution. In addition, the shade from the solar panels may help reduce algae growth in the water, which can contribute to better water quality. Therefore, floating solar projects support both energy production and environmental protection. Although floating solar projects offer many benefits, they also face several challenges. One of the biggest challenges is the high installation cost. Special floating structure, anchoring system, and electrical equipment are required to support the solar panels on water. As a result, the initial investment is usually higher compared to conventional solar farms. The second challenge is maintenance. Since the equipment is constantly exposed to water, humidity, and changing weather conditions, there is a greater risk of corrosion and damage. Maintenance activity can also be more difficult because technicians need to access the floating platform safely. Weather conditions can also affect the performance and stability of floating solar system. Heavy rain, strong wind, storm, and fluctuating water level may impact the installation. In addition, environmental studies are needed to ensure the aquatic ecosystems are not negatively affected by the project. In the future, artificial intelligence (AI) is expected to improve the operation of floating solar systems. AI can monitor the performance of solar panels in real time, identify flaws quickly, and predict maintenance needs. This technology can help increase efficiency while reducing maintenance costs. Another future development is the improvement of solar panel efficiency. Researchers are continuously developing advanced solar technologies that can produce more electricity from the same amount of sunlight. The cooling effect from the water surface may also help the panels operate more efficiently. Floating solar projects are becoming increasingly popular across Southeast Asia. Countries such as Malaysia, Thailand, Indonesia, and Singapore are investing in this technology to meet their renewable energy goals. With abundant sunlight and many water reservoirs, the region has great potential for future floating solar development.
Floating solar is an innovative technology that turns unused water space area into sources of clean electricity. It provides a practical solution to Malaysia's increasing energy demands while protecting valuable land resources. Just as we use every part of our house efficiently, floating solar shows how we can make use of available water spaces to produce energy in a smarter way. With continuous developments and improvements in technology, floating solar projects have the potential to become an important part in Malaysia's future renewable energy system. Thank you.
Thank you for lending your time watching this video. Bye!